So, when you stand in front of a mirror, there's this implicit trust.
Yeah.
You raise your right hand, and the reflection raises its left.
Right. It's just a perfect instantaneous simulation of reality.
Exactly. And you never really question the physics of it, right? Light bounces off the glass, hits your retina, and, that's it.
Yeah, the mirror isn't, thinking about your hand.
No, not at all.
Yeah.
It isn't processing the concept of a hand, it's just reflecting. But suddenly, imagine you raise your hand, and the reflection hesitates.
Oh, that's creepy.
Right, just for a fraction of a second. Or worse, instead of mimicking you, the reflection offers you a high five.
Yeah, in that horrifying moment, the glass isn't just reflecting anymore, it's participating.
Yes. And right now, as we look at large language models, we're all basically staring into that glass. We're doing a deep dive today with a massive stack of research, ranging from the philosophy of semantics to cognitive UI design. And the mission of this deep dive is to answer one really massive question for you. Are these machines just bouncing our words back at us like a parlor trick? Or is there actually a mind behind the glass? Do they understand us?
It is arguably, well, the defining question of our era. Because if they do understand, rather than just simulate, we're looking at a required philosophical shift in how we even categorize intelligence itself.
Which is huge.
It really is. We are confronting the idea that our definition of understanding might be heavily biased by our own biology.
Okay, so let's unpack this from the foundation, because to figure out if AI can understand us, we first have to look at how the architecture of intelligence has actually shifted. The AI we're talking about today, these huge language models, they do not think like the computers you and I grew up with.
Not at all. I mean, historically, artificial intelligence was built on a symbolic paradigm.
The old school stuff.
Right, old school. It was entirely logic-inspired. Think of it as engineers hand-designing rules of inference. They were just hard-coding knowledge into a system, and it relied on sequential reasoning to manipulate symbols.
So the system did absolutely nothing unless a human programmer explicitly wrote a rule for it.
Exactly. Zero autonomy in learning.
It's like giving a computer an incredibly strict recipe to bake a cake. It measures the flour, it cracks the eggs, sets the timer, but it has zero concept of what a cake actually is.
Or what it tastes like.
Yeah. Or why you would even want one for a birthday. It's just blindly following a manual line by line.
And because of that architecture for decades, the ultimate argument against AI ever achieving true understanding was philosopher John Searle's famous Chinese room thought experiment.
Oh, right, the Chinese room.
Yeah. So Searle asked us to imagine a person locked inside a room. And this person speaks only English. Through a slot in the door, people slipping pieces of paper with Chinese characters written on them. Now, the person inside has no idea what the characters mean. Nothing. However, they have a massive, impossibly thick English rulebook.
Right, so they flip through this rule book, find the symbol they just received, and the book tells them exactly which Chinese character to slide back out under the door.
Exactly. So to the people standing outside the room, the system appears to speak fluent Chinese. You ask it a question, it gives a perfect answer.
But inside the room, there is zero comprehension.
None. There is only a person sweating over a rulebook, performing mindless symbol manipulation. Searle argued that a computer is just that room. It shuffles symbols based on programmed syntax, but it never, ever grasps the semantics.
Meaning it doesn't get the actual meaning of the symbols.
Precisely.
But Searle's argument was completely tailored to that old symbolic recipe following AI. The paradigm shifted completely when we moved to brain-inspired connectionist models, right? Modern neural networks, like the transformers powering today's models, they don't have a rule book.
No, they bypass the Chinese room entirely. Instead of following rigid, hand-coded rules, artificial neural networks learn representations directly from massive data sets.
By tweaking connections.
Yeah, by tweaking the connection strength, the weights and biases between artificial neurons. When an AI reads billions of pages of text, it isn't being told what the grammar rules are. It's organically mapping patterns. It's shifting the numerical weight of its own connections to predict what comes next.
So there's no guy sitting inside blindly following a manual. The system built its own internal architecture based on exposure to data.
Exactly. It's fundamentally different from the Chinese room.
But wait, critics still use the syntax versus semantics argument against neural networks all the time. They argue that even if an AI builds its own map of patterns, it still only possesses syntax.
Right, the structure.
Yeah, they say it knows the mathematical structure of the words, but it's completely divorced from semantics. It knows how words fit together, but it's an empty shell when it comes to what those words actually mean to a human being.
And that's where the philosophical research in our sources gets really interesting, because it tackles this exact criticism. The authors argue that this supposed chasm between syntax and semantics is basically an artificial distinction.
Really? How so?
To explain why, the research introduces a fascinating breakdown using Morse code.
Oh, let's dig into that, because I found the Morse code analogy to be the perfect way to visualize this for the listener.
So think about the foundational elements of Morse code: dots and dashes. For Morse code to even function as a system of syntax, for there to be any rules at all, the system must fundamentally be able to tell the difference between a dot and a dash.
Well, yeah, obviously.
It sounds obvious, but that basic distinguishability is crucial. The fact that a dot registers as a distinct entity separate from a dash is a form of self-reference. The dot is essentially saying, I am this token and I am not that token.
And the researchers argue that this foundational ability to differentiate tokens is actually a form of minimal semantic content. Like, you can't even have the structure of syntax without some foundational level of meaning, even if that meaning is just, I am different from you.
Right. If a system can differentiate tokens, syntax inherently implies semantics. Pure syntax, entirely divorced from any form of meaning, it doesn't actually exist in a functional system. The moment you have a structure that recognizes differences, you have the very bedrock of semantics.
Okay, here's where it gets really interesting, but wait, I have to play devil's advocate for you here. Let's say a dot knows it's a dot, and a dash knows it's a dash. That is light years away from knowing that a specific arrangement of dots and dashes represents the concept of nostalgia or grief.
Oh, absolutely.
How do we cross the bridge from basic token recognition to deep, rich human meaning? Like, if I'm a machine, knowing the word rain frequently follows the word heavy doesn't mean I know what it feels like to be caught in a storm.
What is fascinating here is that you're pointing to the concept of referential grounding.
Referential grounding.
Okay. Yeah, this is the classic philosophical argument that true meaning requires a physical body experiencing a physical world. It's the idea of the pointing game. If I want to teach you the word cat, I point to a physical cat sitting in the room.
Right.
For a long time, philosophers argued that without this physical referential grounding, an AI is basically trapped. It's just playing an empty game of matching dictionary words to other dictionary words without ever touching reality.
Because if you only ever read dictionaries, you're trapped in a circle of text. I know what an apple is because I've felt the wax on the skin, I've heard the crunch, I've tasted the sweetness. The AI has only ever seen the letters A-P-P-L-E.
But the source material takes a hammer to that assumption. It argues that demanding referential grounding is an illusion.
An illusion. How?
The research cites the philosopher Karl Popper, who completely deconstructed the pointing game. Imagine I point at a physical red ball to teach a toddler the word ball. How does the toddler know I am pointing at the object's shape and not its color, or its bouncy texture, or the fact that it is a toy?
Oh, wow. Because the physical act of pointing is completely ambiguous.
Exactly. Pointing at a physical object does not magically transfer the universal meaning of that object into someone's brain. An immediate physical experience is unique, chaotic, and it happens only once.
So what's actually happening then?
When you point at a cat, you are merely linking a sound, the word cat, to a person's internal mental representation of a cat. The meaning doesn't live in the physical animal, it lives in the conceptual avatar inside the mind.
Oh, I see. So when I read a dictionary definition of a word I've never heard before, I use the words I do know to build an internal conceptual image of it. I don't actually need to physically touch the object to understand it.
Precisely. And if we connect this to the bigger picture, escaping the circle of words is a myth even for humans. Human language doesn't directly represent the external physical world. It represents our conceptualized world.
We're already operating in a layer of abstraction.
Exactly. And AI has full, unrestricted access to that exact same conceptualized world through our written data. It reads billions of pages of our thoughts, our descriptions of apples, our poems about rain.
Right.
Demanding that AI touch physical objects to understand language is applying a double standard, because even human meaning is fundamentally conceptual, not strictly physical.
That is a massive paradigm shift.
Yeah.
But if meaning doesn't come from pointing at physical objects, where exactly does it live? If it's not the physical cat and it's not some magical dictionary definition locked in a vault somewhere, what actually is meaning?
It lives entirely in the relationships between words. The research introduces frameworks known as inferentialism and semantic fragmentism.
Inferential, okay.
In these frameworks, a word doesn't have an essential core of meaning hidden inside it like a pit in a peach. Its meaning is entirely defined by how it is used in context, its relationship to all the other words around it, in a bounded fragment of language, which computational linguists call a corpus.
Okay, let me try to map this out for the listener. The word bank has absolutely no meaning in a vacuum. It only acquires meaning based on its neighbors.
Right.
If it's surrounded by words like river, water, and mud, it means one thing. If it's surrounded by money, vault, and robbery, it means something entirely different. The meaning is the relationship.
And this brings us to how large language models actually process language under the hood, which directly answers whether they understand us. LLMs don't just probabilistically guess the next word by looking at the last 3 words you typed. They map multidimensional vectors. We are talking about word embeddings, the foundational technology behind models like GPT.
Let's break down vector math, because when I first encountered this in the sources, it completely blew my mind.
It is wild. Imagine a massive multidimensional space. Not just 3D space like a room, but thousands of dimensions. Every single word the AI has ever learned is assigned a specific coordinate in this massive space based on the context it usually appears in.
So words that appear in similar contexts cluster together.
Yeah.
So dog and puppy are sitting right next to each other in this massive mathematical galaxy. But the relationships are so precise that you can actually do math with the concepts. Like the classic example in the research is taking the vector coordinates for the word king.
Yes, the king example.
If you take the mathematical location of king, subtract the vector for man, and add the vector for woman, the resulting coordinate lands almost exactly on the word queen.
That vector math proves that the AI isn't just memorizing strings of text. It has captured incredibly complex, hidden patterns of context. It mapped the conceptual relationship between gender and royalty purely through exposure to how humans use those words together. Every word is a coordinate in a web of relations.
So what does this all mean for the listeners? Meaning is just the relationship between concepts, and the AI has flawlessly mapped those relationships in thousands of dimensions. Does that mean the AI's understanding isn't just a parlor trick? Like, is it actually duplicated understanding rather than simulated understanding?
That is the controversial but logical conclusion of the research. If language is fundamentally a complex system of relations, then a sufficiently advanced non-biological system mapping those exact relations is exhibiting genuine understanding.
It's really doing it.
It is fully participating in the language game. We have a deeply ingrained human bias that assumes conscious awareness or a soul is a strict requirement for understanding. But structurally, syntactically, and semantically, the machine is performing the exact same conceptual mapping that our biological brains perform unconsciously.
That is a bitter pill for human exceptionalism. We like to think our consciousness is the secret sauce of comprehension. It forces us to shift our philosophy and accept that a non-biological system running on silicon can truly understand the language we speak to it.
It's humbling.
But wait, before we assume these models are completely omniscient, the sources do reveal a massive fundamental limitation in how AI thinks. And this is where we get into the research on UI and UX cognitive feedback and the mechanics of human creativity.
Yes, this is a critical distinction. While the AI understands the semantics of language perfectly, we have to look at its underlying cognitive architecture. AI operates entirely on symbolic logic.
Symbolic logic.
Yeah, it deals in timeless patterns, equations, and what psychologists call crystallized intelligence. Crystallized intelligence is knowledge built entirely from prior experiences, historical data, and established facts.
So to bring in the UI UX design research from our stack, it's like a design AI that knows all the rules of a good interface. It knows perfectly well that a gray button means disabled or unclickable. Why? Because it has analyzed millions of human interfaces. It has perfect crystallized knowledge of the rules of human design.
But what it lacks is narrative cognition.
Narrative cognition, what's the difference?
Narrative cognition is a deeply biological process. It's the understanding of cause and effect, the passage of time, and physical processes. Logic, by its very nature, exists in an eternal present tense. In an equation, 2 + 2 = 4 forever. It doesn't matter what time it is. But narrative exists strictly in time. A cause must precede an effect.
Hold on, I need to work through this. If the AI truly understands language through those multidimensional vectors we just talked about, how can it be blind to cause and effect? Isn't causation a huge part of human language? It's read millions of books where characters cause things to happen.
This raises an important question, and the answer goes down to the literal physical hardware of the machine. Computers are built on logic gates. They process equations. And mathematical equations treat both sides of the equal sign as perfectly symmetrical. So, to an AI, causation is inherently flattened into correlation.
Can you give me an example of that flattening?
Sure, if an AI reads massive amounts of human data, it learns that fire is highly associated with smoke. It maps those vectors closely together, but mechanically, its logic gates treat them symmetrically. Fire equals smoke, and therefore smoke equals fire.
Oh, I see. So without an understanding of the arrow of time, the AI might logically infer that smoke causes fire. Or, to use a real-world data problem, it might analyze city data and conclude that hospitals cause sickness because sick people are statistically clustered at hospitals.
Exactly. It sees the correlation perfectly, but the causal arrow is completely invisible to it.
That's a huge blind spot.
The machine perfectly maps the semantics of the language, but it fundamentally lacks the biological action neurons that evolved in humans. Biological creatures evolved in dynamic, dangerous, unpredictable environments. We developed action neurons to navigate instability, to avoid predators, to plan for futures that haven't happened yet.
Right, we're constantly anticipating.
Humans run temporal what-if scenarios in our heads that aren't just statistical probabilities of the past, but entirely new, unprecedented causal mechanisms.
So the AI is essentially a perfect mirror of what has already happened. It's an incredibly powerful meaning maker, mapping all of our historical concepts and relationships in that massive multidimensional space. But because it lacks lived biological experience in a temporal world, it has no narrative creativity. It can't run a simulation of an unprecedented future.
It is fundamentally limited to the boundaries of the data we feed it. It can remix our past with astonishing superhuman fluency. It can write a poem about rain in the style of Shakespeare that will literally bring you to tears because it understands the semantic weight of the concepts.
Yeah.
But it cannot organically invent a new why or a new how, the way a human child does when they encounter something truly surprising in the physical world.
It's brilliant at logic, but terrible at story. Let's pull all of this together for you. We have been on quite the journey today. We started by looking at how AI evolved from rigid, symbolic rule following, that guy locked in the Chinese room sweating over a rulebook, into brain-inspired neural networks that organically map patterns. We explored why pure syntax doesn't really exist, and how even the basic distinguishability of a Morse code dot carries minimal semantic meaning.
And we unpacked the myth of referential grounding. We realized that humans and AI both operate in conceptualized worlds, not just physical ones. And we walked through the vector math to see how true meaning lives in the vast web of relationships between words, a multidimensional space that AI maps with terrifying precision.
Which forces us to concede that its understanding of language is a duplication of our conceptual maps, not just an empty simulation.
But we also found the boundary of that intelligence. Despite its genuine semantic understanding, its purely logical architecture built on logic gates rather than biological action neurons restricts it from true narrative creativity and causal reasoning. It's a master of the present and the past, but it lacks the temporal cognition to be the author of the future. It understands what we have been, but it cannot decide what we should become.
It's a profound realization. We've created a non-biological system that genuinely participates in the human language game, yet remains fundamentally blind to the arrow of time.
It really is incredible.
And that leads to a final thought I want to leave you with, to just mull over on your own. If AI's true understanding comes from mapping the relationships between human words in massive data sets, what happens in a few years when the vast majority of the text on the internet is generated by AI itself? As its perfectly logical, correlation-heavy text floods the digital world, will human language slowly begin to map itself to the AI's understanding rather than the other way around?
That's a wild thought.
It brings us right back to that mirror we started with. If we stare into it long enough and the reflection starts participating, do we eventually start copying the reflection?